Well, it's going to gradually fall into the mountains. The mountain streams are going to run it into the rivers and out. Now, I was in Niigata, which is on the Sea of Japan. It's on the west side of Japan. It's almost at the same height as Fukushima, but there's a mountain range that runs down the center of the island in between, and the rivers and streams in Niigata were highly contaminated. The sediment, the mud at the bottom of these rivers and streams, were highly contaminated with cesium that was coming out of the mountain range in between these two halves of Japan, if you will. Well, what that means is that the radioactive source is now spreading out. We're not just seeing cesium being released from Fukushima Daiichi and the leaks into groundwater and the leaks directly into the ocean, but we're seeing all the rivers and streams as they come out of the mountains into the Pacific on the east coast and into the Sea of Japan on the west coast are also carrying cesium, which is going to work its way up the food chain and contaminate freshwater as well as saltwater fish.
Arnie, is cesium the only isotope being found in these fish?
No, that's a really good point, Kevin. If cesium is the easiest one to measure, you can put it into a radiation detector and you'll pick it up quite easily. It emits a very distinctive energetic ray, and you can pick it up pretty easily. But when you see cesium levels as high as 11,000 becquerels per kilogram, what that means, 11,000 disintegrations per second for every 2 pounds of meat, there's also got to be strontium-90 as well. So strontium-90 is in the bones of the fish. And, people say, well, I don't eat the bones, so I don't have to worry about the strontium-90. But the Japanese make stew with fish, and the entire fish is cooked in stew, which then liberates the strontium-90 to then go into them and their kids and future generations. The difference between cesium and strontium is that cesium is a muscle seeker. It goes to heart muscle, it goes to your body's muscles, and that's why you find it in the meat of a fish, which is muscle. Strontium, on the other hand, is a bone seeker, and it goes to your body's bones, your body's teeth, especially in rapidly developing infants. That obviously your bones are requiring lots of calcium. Strontium is identical to calcium, so that it gets absorbed in the bones and is likely to cause leukemia. So it's when you see the presence of strontium, it's a leukemia precursor. And 20 or 30 years from now, we're going to see an increase in leukemia as a result of the strontium plant release.
And what might cesium be related to?
Well, cesium will cause other cancers, not leukemia. What they call hard tumor cancers are caused by cesium. The reason strontium is so hard to detect is because the ray it emits is quite hard to detect. So what chemically has to be done is they have to separate out the bone, and then within the bone they have to separate out the calcium and put it in a detector and look for another isotope called yttrium. Strontium decays to yttrium, which is pretty easy to detect. But that whole process takes as long as a month to chemically do the separation and put it in the detector. So you'll hear scientists talk about cesium as if it were the only thing. But in fact, it's pretty obvious to me that when you see 11,000 disintegrations per second in fish, you're also going to see strontium in their bones.
So easier to detect cesium. Arnie, what should the Japanese be doing about this right now?
Right now, there has to be health warnings out to people about eating freshwater fish. People that just have as an avocation, fishing in Fukushima Prefecture are very likely to be catching fish that are highly contaminated. The people that need to feed their families by catching fish are very likely to be contaminating their families. Now, what the Japanese are doing is watching these fish as they go to market, but not all of them, and so it's a random sample. And but I don't believe that the health warnings the Japanese government has put out are adequate considering the numbers we're seeing. Well, it's not just the trout. We've seen it in bass, and we've seen it in catfish as well, and not just in Fukushima, but in surrounding prefectures. So the problem is large in area, and the concentrations are not inconsequential. The Japanese government's position here is that don't worry, be happy, it's not going to hurt you. And in fact, over time, it is going to hurt a significant number of Japanese, and the government's got to step up here and admit that this is a serious health risk.
Right. For those of our listeners who are interested in reading that Japan Times article, you can find it under this podcast on the fairewinds.org webpage. Moving on, but sticking with the topic of contamination, a few months ago you had taken soil samples in Tokyo and you found high levels of radiation in the Tokyo soil samples. But now some new information that new data, I should say, that may confirm the samples that you took back then.
Yeah, our readers may remember when I came back from Tokyo back in February, I had 5 samples of dirt that I had taken just randomly around the city, and they were all over 7,000 disintegrations per second in a 2-pound bag. So what that told me was that the releases from the accident were really severe, even as far away as Tokyo. And I said then that if this were contaminated ground at a nuclear power plant, it would have to be considered as nuclear waste. Well, we took a lot of flack for that on the Fairewinds site, but we were right on the mark. What just happened just last week was that in a suburb of Tokyo, another sample was taken by citizens, and they brought it to the attention of the government that then sampled it. But basically, they had a hot spot that was in excess of 10,000 disintegrations per second per kilogram of their sample. So here we are 9 months after I took my samples, and citizens are still finding hot spots all over the Tokyo area. I think it speaks to, one, the magnitude of the initial release. This was a serious release, not just for Fukushima Prefecture, but for Tokyo and its suburbs as well. Tokyo is 130 miles away. This is not around the corner. These high concentrations detected in Japan really speak to emergency planning elsewhere. I mean, Tokyo is 130 miles away from Fukushima, and here's New York City, 26 miles away from Indian Point, or L.A. is 50 miles away from the San Onofre reactors. So if Tokyo could be highly contaminated to the point where its soil should be shipped to a nuclear waste dump, what should the United States be doing when we've got nuclear plants that are much closer than Tokyo was to Fukushima? Tokyo to Fukushima is 130 miles, and here LA is 50 miles from San Onofre, and New York City is 26 miles away from Indian Point. If Tokyo can have soil so hot that it should be shipped to a radioactive dump, what might happen to our nation's capital, the biggest city in the United States, or to LA in the event of a nuclear accident? We're really not prepared, and we have our policymakers at the Nuclear Regulatory Commission have not even envisioned that as a possibility.
All interesting information, Arnie. I want to also remind our listeners that this Wednesday we'll be publishing a special edition podcast to talk about issues happening within the United States. Arnie, could you just give us a little preview of Wednesday?
There's a lot going on in the United States that would make this podcast way too long. There's issues related to losing the ability to cool the nuclear reactor in the event of an accident. We call that loss of an ultimate heat sink. There's been containment damage detected at a couple of nuclear reactors now. The biggest problem on the horizon is cost. Several nuclear reactors now have announced that they are considering permanently shutting down because the cost to keep them running is just too high. So we'll address all of that over Thanksgiving turkey in the middle of the week.